If you want to get from point A to point B as fast as possible, your instinct is to move in a straight line. But in the physical reality of our universe, a perfectly straight path actually takes the absolute longest amount of time. We spend our lives trusting a simple rule of geometry. The shortest distance between 2 points is a straight line. It's an assumption so deeply ingrained that we rarely think to question it. This is because human biology is strictly hardwired to perceive only 3 dimensions: height, width, and depth. Our senses evolved to navigate a 3D world, and they don't naturally register anything beyond those coordinates. Because of this biological limit, your daily navigation, from walking across a room to driving across a city, is based on a fundamental misrepresentation of how the universe is actually structured. The universe does not operate in simple 3D space. To map any event, you must add a 4th coordinate, time. Together, these form spacetime. This inverts standard geometry. Because time is a physical dimension, distance isn't static. It changes based on the observer's movement. In a space-time reality, the basic geometric rules we are taught in school are revealed to be an illusion. For centuries, classical physics followed Isaac Newton's theory that time was a rigid, absolute constant. Stephen Hawking described this model as a universe governed by a universal ticking clock, one that flows at exactly the same rate for everyone, regardless of where they are or how fast they're moving. This rigid framework perfectly matched our intuition. After all, a clock on a wall and a watch on a wrist appear to tick in perfect synchronization. But as humanity began to observe the universe at higher speeds, it became clear that this Newtonian model was an incomplete picture of physical reality. The shift began with Albert Einstein, who realized that the absolute nature of time was a mistake. Einstein's core discovery was that the speed of light never changes. This creates a mathematical problem. Speed equals distance divided by time. If the speed is fixed, but the distance between 2 observers changes because they are moving, then time is the only variable left that can shift to make the math work. For the speed of light to remain constant, time and space must be fluid. This leads to the geometric proof used by physicist Sean Carroll. In the 4-dimensional math of spacetime, a straight path between 2 events yields the longest elapsed duration of time. Time is not a background clock. It is a physical property dictated by the specific route an object takes through space. We can see this in the twin paradox. Imagine one twin stays on Earth while the other is launched into space at a speed near the speed of light. To stay still on Earth is to move in a perfectly straight line through spacetime. For this twin, time ticks away at its maximum possible rate. But the twin in the rocket must accelerate and change direction to return home. This acceleration creates a curved path through spacetime. As that curve steepens, the intervals of time stretch out, causing the traveler's clock to slow down. When they reunite, their clocks show a massive divergence. The twin who took the curved path is younger, having experienced less time than the twin who remained on the straight path. Moving in a curved path through space literally slows down the rate of biological aging relative to traveling in a straight line. This means that universal time is a fiction. There is no single shared clock for the entire world. Instead, time is local. It exists as an isolated bubble around you, dictated by your specific movements and the physical geometry of your path. While we rely on synchronized schedules and watches to run our society, we do not actually share a true synchronized chronological reality with anyone else on the planet. This isn't just a theory for astronauts. Every time you accelerate in a car, change direction on a walk, or slow down your pace, you are physically shifting the flow of your own timeline. Every physical movement you make determines the rate at which the biological clock ticks inside your own cells. The specific route you take through space determines the speed of your biological aging. Moving in a straight line isn't just the shortest distance, it is the fastest way to reach the end of your life.